Hi, my name's Will Crawsick, Scientific Services Manager at Chemical Computing Group. Today I'd like to show you how to prepare a raw PDB file that contains a protein-protein complex. In this particular example, we'll be using an antibody-antigen complex, but this could be applied to any protein or proteins that do not have a small molecule bound. Once prepared, the 3D molecular structures can be used for tasks such as interactive analysis or for docking. So let's get started. So I'm just going to retrieve the file that we'll work on today using the Open button. From here, I can download PDB files directly from our CSV. But today I'm going to navigate to the gold star on the header where I have access to my downloads or desktop. Here I'm going to select $mo sample mol and I'll select the sample file that we're going to be working on. I'll select it in the Open panel, hit OK, and I'm greeted with this Load PDB file panel, which allows me to select what data to load into Mo. If I was handling a multimeric protein, this would allow me to bring in the biomolecule assembly. In this case, though, we don't have such a scenario, so I'll just accept the defaults with OK, and we see here the structure of interleukin 13 shown on the left-hand side, predominantly with the yellow beta sheets, bound to an antigen shown on the right here, predominantly with the red helices. With this being a raw PDB file, typically it's not going to have any hydrogens, charges won't be calculated, and it might be missing some loops. So before we can get into any interactive analysis, the first thing we need to do is prepare that using QuickPrep. There are three main phases to QuickPrep. The first handles the preparation and cleanup of the structure, second sets tethers and restraints, and the third handles refinement. I'm going to make one small change to this panel before I hit OK. I'm just going to toggle off the fix option, and I'll explain why in just a moment. I'll then start the calculation by clicking OK, and I get a progress update at the top left of the main Mo window. So I'm just going to reopen QuickPrep to explain what's going on in the background. So the first stage of QuickPrep is preparation to ensure that our model is complete. Here we add in our missing hydrogens, charges and side chains. We'll also build any missing loops up to 10 residues in length or terminal outgaps up to 5 residues in length. As part of preparation, we'll be running the Protonate 3D application, which optimizes the ionization states of bound molecules and their side chains, and also generates a hydrogen bonding network through the placement of polar hydrogens. As part of this, we'll allow asparaginins, glutamines, and histamines to flip so that we can optimize that H-bond network. Next, we decide what to do with waters, and by default we'll be deleting any water molecules further than 4.5 Armstrongs from any ligand or receptor atom. Next, we set our tethers and restraints. By default, we'll be tethering our atoms, and that's applied to all receptor atoms. You can think of a tether like an elastic band, which allows the atoms to move, but if they move too far from their original geometries, the elastic band will pull them back to the original starting position. This way we don't deviate too far from the original crystal structure geometries. Next comes the fix option, the one that we toggled off before running the calculation. Normally, it allows us to fix any atoms 8 Armstrongs or further away from a ligand, which is a great idea to prepare a model that has a ligand bound to the receptor and we want to focus on the binding pocket. In this scenario, we don't have a ligand, and I don't want to fix the entire complex, so for that reason I toggled it off. Note that if this is a common option, meaning that I don't work on small molecules very often, I can adjust the defaults in this panel. The final part of QuickPrep is refinement, which performs an energy minimization to ensure that we don't have any clashes in our structure. I see the message has gone from the top left of the main Mo window telling me QuickPrep is now complete. I'll just go ahead and open the System Manager, as the name suggests, to manage the data that we have in our system. From here I can hide and show atom sets, I can make selections, I can also render and generate surfaces. Within the System Manager, I can see that 2 sets have been created, and if I just click to expand, these give me information to the sets of atoms that have been corrected as part of the structure preparation. With that, it brings us to the end of today's session. where we learnt how to prepare a raw PDB file. This prepared file might now be used for different applications across Mo, protein-protein docking as an example. If you have any questions, please do reach out to us at support@chemcomp.com.